So welcome to our OTS Connect session, Math Tasks to Support the Progression and Development of Multiplication and Division with Kit Luce. It's great to see people from all over Ontario joining us for these OTS Connect sessions. And I'm just going to turn it over to Kit and get her to introduce herself and get going on this great webinar.
Okay, so welcome everyone. As I said earlier, feel free to jump in with the mics. Just turn them on when you want to talk and turn them off when you're not. Or type in the chat box. We'll be going back and forth with some interactive things. The first slide here, you can see the bit.ly. So the bit.ly/OTF and div. That's for those of you who are Google Drive users, that will give you this slide deck, and you're welcome to add it to your own drive, but you know that the recording will be available on the OTF site, so you'll have the whole PowerPoint with all of the links, but you can access it either way. So, my name is Kit Luce. I live in Barrie, Ontario. I'm a teacher with the Simcoe County District School Board, and this year I am working with two schools, two of our intensive support schools, directly with mostly grade 4, 5, and 6 teachers, and our title is Instruction and Assessment Facilitator, but essentially I'm a math coach. And that's my email there, and my Twitter. Yeah, I can go back while I talk. There's the bit.ly. I'm fairly active on Twitter, so I'd love to continue the conversation there. And you'll have my email, and I'm always happy to talk math anytime. So if you have questions going forward, please don't hesitate. I like to reach out. And I always like to put up a couple of pictures just because you only hear my voice. And, you know, it's who is this person talking? So that first picture there is my family. You can tell that they're all much taller than I am. But they're adults now. So I have time in the evenings to do this kind of thing. I'm past the waiting minute or trying to get my kids to go to bed. And the bottom picture shows our two dogs, the two Goldens, and the third little dog there is actually a retired sled dog. Mally and I were talking, she'd just almost gone sled dogging this winter, but so that little thing there doesn't look like a sled dog, but she is, and she belongs to my son. So a little bit about me and who I am. So let's get started with some math. So my question for you is this, is how many legs and how did you figure it out? So feel free to turn on your mic and talk or to type in the chat box. How many legs do you see and how did you figure it out? So Sharon sees 6 bugs with 6 legs each, 6 groups of 6. And when we're talking 6 groups of 6, is 6 times 6 a multiplication fact you just know? Is it something that you have to think about and figure out, or is it one of your, is it one you already own? Okay, and with our kids, as they start to learn multiplication facts, that 6 times 6 is often one they learn quickly. Just like the doubles with addition, they seem to learn the doubles with multiplication too. So that's something that's important to know about our kids, is which facts do they own and which facts do they need to use other strategies to get at? Okay, so that's our start. What about this? How many dots? How did you figure it out? So I see 7 times 9, 7 dots times 9 groups. Okay, and when you're seeing the 7 dots, can I ask how you figured out there were 7? Did you count them by ones? Did you see pairs? So Deb, I looked at 3 times 3 first. Sorry, I'm going to go back up here. I looked at 3 times 3 first, then counted small dots in groups of 2, plus 1, then multiplied. Okay, so you saw, I think I can draw right on this, right? Maybe not that one. You saw 3 groups.
Yeah, what you can do is on the whiteboard tools, just activate the pen.
Yep.
And draw.
Perfect. Okay.
Just like this.
So those 3 and those 2 and those 2. Awesome. Okay. And some of us counted them all by ones. Kate, you saw pairs. Annick, you saw 2 plus 2 plus 1, counted by ones, counted by twos. Right? And then Jan, you saw the 2 and the 3 and the 2. So again, that's really interesting with kids to see how they saw them. So I saw when I did this a 5 and then a 2, and that's how I knew there was 7. And it's interesting because some of the research says that we can't subitize or recognize more than 7 objects at a glance unless it's organized in some way. And so if they were just scattered, we would have to count by ones if they were 8, 9, or 10 dots. But if they're grouped in some way, then we can recognize 4 and 4 and put that as in 8. So that's really interesting when you're doing images or gathering a group of objects for kids to see how they see them and how many they can see it at once. And Kate, you said, I didn't see the 5 at all. And I know I've seen kids who say, I saw, I'm going to do this again. This is the first time. I saw 3 and 3, and there should have been 3 here, but 2 were missing. So I knew it was 9, take away 2. And I always find it really interesting when kids see that negative space, because that's not a way that I view the world. But there's a lot of kids who can see that negative space, and that's kind of interesting. All right, now I just want to make the pen go away. There we go. Nope. Okay, well, hopefully it won't be there. All right, count stars, and how did you count them? So Emily counted by 2s, and Emily, when you said you counted by 2s, did you skip count up, or did you multiply by 2s? Okay, so Emily, you skip counted. Marlene, you combined the twos, 4 groups of 2 to get 8 and then multiplied by 3. And Sharon, you did something similar. So Jan, you have 4 times 6. That's interesting. So you saw this group of 4 and did it 6 times. Awesome. And Deb, you found the 4s, made it 8, and then doubled from there. 12 in each row and doubling. And you'll notice on the slide decks, I've put the links for where I got these images from. And so this one is from a website called Math Before Bed. And it's often a website I recommend to parents when they want to, you know, can you send home math worksheets for my kids? And especially in primary, what I tell them is, I just want you to talk about math with your kids. Look for opportunities. And maybe in addition to that story time at bedtime, maybe you can talk about the math in the stories you're reading. And Math Before Bed is a great website. All right, we have a couple more. How many holes? How did you count them? So 12 holes in 1 pretzel, and there's 9 pretzels, so 12 times 9. 3 rows of 4 holes times 9. Marlene, 3 times 4 times 9, and you used a calculator. Michelle, you asked a partner. Awesome. And Kate, when you counted, did you count by ones? By 4s, thanks. And it's interesting as adults, we see the world in an interesting way. None of you counted the holes in between. So these holes here, and I've had kids do that as well with this image. And this image comes from a website called ntimages.weebly, and it has wonderful photographs to use for number talks. It has dots, the photo dots, and that's where I got the other dot one from. So Number Talk Images is a great website to get images from. I chose one to provoke this multiplicative thinking, but there's lots of different ones you can use. Okay, we have 2 more. So this one is interesting, and I'll reference this again. How many cups, and how did you count them? Because you can't see all the cups this time. So how many cups are there in total? And then a follow-up question is that if you had 8 tables, how many cups could you put on each table? So 3 cups in each stack, 4 stacks in a row, so a 3 by 4 by 4. So that's almost like a volume formula there. Top row of cups, so this whole row multiplied by 3 layers. So that array model here. Again, 4 times 3 times 4 rows. Three cups and 4 columns, yeah. Yes, Sharon, each table, this is the total number of cups that go on 8 tables. So whatever we figured out, how many cups there are, how would I divide them evenly amongst 8 tables? So a couple questions I want to ask here. How a lot of you came up with either, and I'm going to do this here. There we go. Oops. 3. How do I make that go away? 3 times 4, and then times 3 times 4 times 4, or 3 times 16. There we go. I have an extra 3 in there, but you can forgive me for that. So 3 times 4 times 4, and some of you ended up with 3 times 16. How did you know what 3 times 16 was? Is that a known fact? Or is there a way you had to figure out? Repeated addition? Okay. And Michelle, when you say repeated addition, did you do 3 times 16, or were you doing 12 times? Okay. Or were you doing 12 times 4? Deb, you were doing doubling and halving. So I'll see back here. Instead of 16 times 3, you made it 8 times 6. So doubling and halving is often a strategy that we use. Kate, you were decomposing. You were splitting 3 times 10 and 3 times 6. And Michelle, you were doing 16 plus 16 plus 16. Awesome. Okay. Last one to get us started. Now this image comes, I pulled it off of Twitter. There was a hashtag, and there still is a hashtag on Twitter called Mathematize This, and it's just images from our communities, our world, and looking at it through a math lens. I happen to know this set of dice comes from a company called Boxcars and One-Eyed Jacks, because we have them in the schools I work in as well. But for this one, how many blue dice? How many white? So how many dice altogether? And then how many dots? How would you figure that out? And we'll leave the other questions for now. Just how many dots and how would you figure it out? I'm just going to try and so we have 36 dice, and some of you did 6 times 3. And if you remember back to our ladybugs, there were 6 legs on 6 bugs. This is also a 6 times 6, but it's organized in an array. So 6 dots on 6 dice, again, it's a 6 times 6 known fact for 36, times 6. And Sharon, you did 30 times 6, so that friendly number, and then added on the other 36. Deb, tell your son that he has to figure it out and tweet it to me, okay? Okay, and I don't think we'll spend some time on the second part of this question that I put in, but it goes into the division. So we've multiplied up to find out, you know, how many dice, how many blue, how many white, how many dots, and then we could use the same image for a division question. How many dice, how many kids would have dice if I gave them 4? And then could they have either all blue or all white? So I wanted to start with that. One is to get our minds thinking about the different ways we multiply. So if we go back to the images, we saw equal groups of things. We saw ways to decompose numbers and then combine groups. We saw organizing into smaller groups, which led into arrays. Arrays here that are with some of the images hidden, so you can't just touch them to count them all, but you have to imagine what's there. And then finally, this level of image where you can ask all sorts of different questions depending on the age and grade level of your kids. So, these are 2 images. Oh, these are 2 images that one is sorry, the turtle had multiplication, and I ran across this last year, and I can honestly say I'd never seen this way of teaching multiplication before. And I could not for the life of me figure out what turtles had to do with multiplication. And the cartoon references that whole idea of gazintas. Deb, you said you've lost the picture? You should see a screen that has a cartoon on it right now. So the cartoon references, how's your homework coming up, Skylar? Well, I got the multiplication figured out, but I'm still having problems with the gazintas. And, you know, what are gazintas? You know, 4 gazinta 20, how many times? Stuff like that. And that was certainly the way I was taught to divide, that long division. And it's still hanging on. I just actually had a conversation with a colleague who has a student teacher, and the student teacher was doing a lesson and teaching division, and was teaching the students Dracula must suck blood for divide, subtract, or divide, multiply, subtract, bring down. And we can do better than this. We can do better than gazintas, and we can do better than multiplication. And our students deserve for us to do better. And when we know better, we do better. I know when I first started teaching, I relied on what I had learned and the way I was taught. But as I learned, I know better and I do better. And so the link here that Mally put in the slide deck is from our effective guides. And it really clearly lays out why we should encourage a variety of flexible computation strategies. Mally, can I ask a question? I see, how do I get rid of the bar here on the tools? How do I make the tools go away? Is there a way I can do that? No? Okay. All right. It's sticking out. I just want to make sure it's not in everybody's way. All right. So tonight, we're going to look at some of the different research that's out there about how children learn multiplication and division developmentally. We have continuums, and we have progressions, and we have trajectories, and we have landscapes. Okay, perfect. I'll drag that down. Thank you. Is anyone familiar with any of these images? We have a continuum here from Alex Lawson, a trajectory from Doug Clements, Fosnot landscape. So Sharon, you've seen the landscapes. Michelle, you're familiar with Alex Lawson's. That's the light green one. Okay. So these researchers, great, Marlene, awesome. Yes, Deb, the first one is Clements. So these researchers, so Douglas Clements, Alex Lawson, who works for Lakehead University in Thunder Bay, Kathy Fosnot, these researchers, they've spent time in classrooms working with students, and they've analyzed and collated the results, and they've each created their own version of what we as teachers have known all along, that students go through a developmental progression as they learn to add, subtract, multiply, and divide. And what happens is that if we push students to become more efficient too quickly, often it results in gaps in their learning. So they might learn a procedure but not really understand what it means. So they might learn about gazintas but not really understand what is happening with division. So we're going to look at each of these a little bit. So Douglas Clements has this developmental progressions, trajectories, sorry, and I have a few links for you. He has trajectories for all different strands in math. Tonight, we're going to focus just on his multiplication and division page. So when this is up on the OTF website, there'll be other links there to all of his trajectories, as well as his website, learningtrajectories.org. But for now, Mally's going to put in the Clements multiplication and division link in the chat box. And when, I hope Molly's going to do that. Oh, there it is, good. I just hadn't moved my thing down. So my own deep learning about progressions began with the work of Douglas Clements. And I'd spent most of my classroom teaching in junior classrooms or in special ed. So I hadn't really developed a strong understanding of how kids develop this early number sense. And so when I came into a coaching role, I needed to learn more. So I knew the name Douglas Clements, and I started there. So what I'd like you to do is to open up that link and just take 2 minutes to look at it, think about it, and then we're going to come back and talk about tasks that you could provide your students to help them move to the next level. So think about the trajectory, take a look at it, and pick something that you want to talk about when we come back. Okay? Mally, can you do a timer for maybe 60 seconds? Is that possible? If not, that's okay. I'll just call everybody. Oh, look at that, magic. Okay, so let's come back to the whole group, and what did you notice? What are you wondering about? Feel free to use your mic to speak to the whole group or type in the chat box. What struck you about Douglas Clements' trajectories for multiplying and dividing? Okay, Marlene, so that idea that young children do divide, and they don't call it that, and they don't even know about, you know, what division is, what equal groups, but they're beginning to get that sense of it in their play, that fair share. Did anything else stick out? The specific ages, like his research really targeted not grade levels, but ages. And I think that's something we often, we get so immersed in what the curriculum is for a grade, and we sometimes forget, especially as the kids get older, that it's their age in those primary grades is really important. One of the things I found really interesting with this, oh, Marlene, absolutely, that students in grade 6, which is a place I spend a lot of my time too, they still need to be at that age 7 step. And they haven't consolidated it. They haven't really developed beyond that. They've gotten stuck there. One of the things I found really interesting was that level 5, the idea that children learn about the inverse relationship between the divisor and the quotient, so that the more people you share with, the fewer items are shared, or the smaller the group. And I think that's really interesting, because I think kids at a really younger age know that the more people that come to share something, the fewer things each of them are going to get. I know they'd figure out that really quickly if it was toys or candy. But I also see that this is the beginning of understandings of fractions, and that understanding of the relationship between the denominator and the size of the pieces. And I was just having that conversation today in a grade 6 class about which is smaller, a 12th or a 9th. And even at that age, kids are saying, oh, 9ths are smaller because 9 is smaller than 12. And so I can see here that helping kids see the connection between the divisor and the quotient in division will really help them when we start talking about fractions. So I really wanted then to develop tasks. to help kids figure this out. So one of the tasks I've done lately with some grade 3 kids, sorry, Sharon, I'm just reading here. Yeah, absolutely the idea that they're too young to understand about the denominator. For me, it was just that connection that at that age, they can start to understand that the more groups you have, the smaller the size of the group, and how that's connected later with fractions. And for me, it meant when I'm working with older students and they're struggling with fractions, maybe this is something I can go back to with them and help them see, oh, well, when you shared 12 things, or shared this group of things with 12 people, you didn't get as many as when you shared it with 9. So it was that connection rather than teaching them about the fractions. So thank you. So this is an image I've been working with with some grade 3 students. And I made meatballs last night. How many people should I invite for dinner? And how many meatballs will they each get? They actually are my meatballs. I didn't make them last night, but one of the things that happens is when you start to spend a lot of time in math is you see it everywhere and you start taking pictures and your family laughs at you. Yes, I was very neat, Mally. I was very proud of myself. So Sharon, yeah, do they have to get an even number? I didn't put that in the question. I just said, how many people should I invite for dinner and how many meatballs will they each get? Now we had the conversation about will they be fair, and typically that everybody gets the same number of meatballs, and it was a way to introduce some division. So Jan says, yeah, 8 people. They get 5 each, and then there's the 3 extra. Okay, and you're giving all of the 3 for me, or Sharon, you're letting me have them for lunch the next day. I like that. And Jan, was there a reason why you chose 8 people? And Emily, you too chose 8 people, or maybe 5 people. I'm not sure. Okay. And Marlene, 21 people, 2 each plus 1 extra. So it was a bigger party, and maybe they were appetizers. And Marlene, where did the 21 come from for you? Is there a reason why you did 21? So yeah, Jan, you saw the 5 rows and 8 columns, and so that popped out at you. Emily, you saw 43 divided by 6. And did you connect that to a multiplication fact that you knew with 6 times 7? Marlene, you went to 42 as well. The closest even number, that's an interesting concept. One of the things I like about this image is that there wasn't a way to divide this evenly, no matter what number you picked, except for 1. 43 is a prime number. We don't introduce prime numbers in grade 3, but we certainly talk about even groups, and then what is the remainder and what do we do with them. Interestingly, kids often talk about breaking the meatballs in half and sharing them that way. So here's some student work. Take a look at those 3 samples. What might you ask? So if you choose one of the samples, what might you ask those students to really consolidate the idea that the more groups you have, the smaller the size of the groups. So the more people come to dinner, the fewer meatballs everybody's going to get. What's happening as you add more people? So the samples I have is, just like we did here, 5 people could have 8 each, and there's 3 extra. We have 2 people could have 21 each, and I think we had that example. Or 4 people could have 10. And then the student at the top actually went to a T-chart. Sharon, I've used this. These examples have come from grade 3. I might use it certainly in grade 4 at the beginning when I'm starting to introduce multiplication. Maybe late in the year with my grade 2s. What do you think, Sharon? Where could you see it living? What grade? Yeah, grade 3, 4, yeah. So you can see this question, this prompt, could really get at the idea that the more groups you have, the smaller the size of the groups. And so that prompt, because I was really interested in that idea of the relationship between the divisor and the quotient, I thought this was a good task to get at that. Yeah, Deb, I think if you might want to use a fewer number of meatballs, but I think certainly the fair share, where they would give 1 meatball to everybody and then 1 more. I certainly have seen 4- and 5-year-olds, put cookies out, 1 per plate, 2 per plate, 3 per plate, and do it that way. Yeah. Okay. So I chose a task because I was really interested in that particular idea, and I thought this was the idea I really wanted my students to understand. So I spent some time with Clements, and then I learned about, I had the opportunity to hear Alex Lawson speak and present her research at a few conferences. And my board made the decision to purchase her book, What to Look For, and we used it in our schools that were getting increased support, and we also used it in our summer learning program. And Alex Lawson, she did a lot of work, research with kids from kindergarten to grade 3, and she really looked at how they demonstrate understanding of the concepts of multiplication and division. Okay, Michelle, you're using this book school-wide. That's great. And what board are you with? Sharon, when do I introduce the language? I start using math language right from the beginning, so divisor and quotient. I pair it with what I mean. So I might say, oh, we're dividing this up into groups, and what's the answer? How many are in each group? We call that the quotient. And I just start to use the language. I don't expect the students to learn the language, and I make sure they understand what I'm talking about. But I'm a firm believer in using really specific math terms when I feel it doesn't inhibit understanding. Okay, so this is an image of the Lawson continuum, and the link that's going to be in the chat box takes you to this continuum, and the multiplication and division is on the 2nd page. So scroll down to the bottom of the doc, and again, take a minute. What connections do you make? So maybe there's a connection to the Clements trajectory that you see. Maybe there's a connection to your own work that you see. And what are you wondering about when you look at the Lawson continuum? So let's take a minute, and I'll call you back when we're done. Oh, Mally, can you put the link in? So the Lawson, there it is. Awesome. Thanks. You're pretty quick on the ball usually. Okay, what do you think? What connections do you make? What are you wondering about? Deb, what is it about? You said you really love how it's organized. What is it about the organization that you connect with? Anything that's really speaking to you? Anything you haven't seen kids do? You're not sure what it means, what her terminology means? Right. So it is very very clear and concise. And the phases, I really like that phase too, because you can see how it's overlapping the big ideas. One thing I noticed about these is that she doesn't talk about age ranges here. That it's more the developmental steps that kids need to go through. I really made a strong connection about students I knew who were seemingly stuck on counting by ones. So even though I knew they could skip count, even though I knew they could double, they would count by ones. And I wanted to find ways to help them move to a more efficient strategy of skip counting. That was the next one. Right? And Deb, you're right, that as they get into more complicated math, they go back. So as we increase the cognitive load for the math concepts, maybe kids need to go back to these direct modeling strategies and move through them for the new concepts. So when we start to work with decimals or fractions or bigger numbers, maybe they need to go back. So I started to use some games in some grade 2 classes where kids were still counting by ones. And we wanted to move them and really help them see that counting by 2s or 3s or 4s was more efficient. So there are 2 games that I've shared here, and as Mally puts them in the chat box, the skip counting race and the target 75. Take a look at each of the games and consider how you would use it with your students. Or how might you modify them? It might modify them to move up for students who need a challenge, or modify it to make it easier. So choose one of them. We won't have time to look at both of them, and you'll have those links for later. But how could you use these games to help kids move from counting by ones to a more efficient multiplication strategy? And we'll just, again, take a minute. All right, and we're back. So can you see these games being helpful in helping kids develop that more efficient strategy? Are these games that you would use with your students? Maybe if you're teaching, I forget who's teaching grade 6. Is there a way you might modify these games to make them useful for older students? Or are there students in grade 6 that are kind of stuck? Okay. Michelle, you like to target 75? Yeah. And I have a game called Target 300, Michelle, that targets multiplying by multiples of 10, so 10, 20, 30, 40, 50, and then it can be modified for multiplying by 100, 200, 300, 400, 500. So if that's a game you're interested with if you're interested in, shoot me an email, and I'll send you the link to Target 300, okay? And Sharon, you would use it with your 6s? Yes, the strategy piece, right? So younger students would just do it and see who can get close. The 6s might start to think about what should my average roll be worth? I've even had kids talk about the mean number. Okay. So sometimes when I want to get at a specific place on a continuum or a trajectory, I think of a problem that will fit. Other times I think, you know, I've done lots of number strings about this. We've done some problems, and the kids just need more practice to become more confident and to develop that more efficient strategy as a default. And I think games are a good way to do that because we can come back to them over and over again. Right? Yes, that confidence, you're right. Really owning it solidly. All right, so we've talked about Clements and we've talked about Lawson, and the next one I want to share is Kathy Fosnot's Landscapes. And I saw at least somebody was familiar with this. Kathy Fosnot has a great number of landscapes. This one has to do with multiplication and division. And I'd been aware of her landscapes before, and I knew about her more with her work with number strings, her mini lessons as she refers to them. But I really hadn't spent much time on the continuum, this landscape, until this year when I participated in an online learning community on Twitter called #Not a Book Study. And I really really delved into this landscape, and at first it hurt my linear brain. I I wanted to see everything laid out neatly. And this landscape of triangles and ovals and rectangles was what? I couldn't make sense of it. And then I had to slow it down and spread it out. And I color-coded, which made me very happy. It was hard to look at. And then I started to break it apart and spread it out. And to be honest, I actually cut it apart and laid them out, because I do think I'm a linear person, and I do think that way, and so it's a good challenge for my brain to think in different ways. But then I began to see the connections between Clements and Lawson and Fosnot. So you've looked at all three now. I'm not going to. There's some more things I want to get to, so I'm not going to spend a lot of time talking about the commonalities, but it's something I'm going to encourage you to do. You have links to all three of them, and find which one are you most drawn to. But I would also challenge you to spend some time on the one that is maybe most challenging for you, and increase your discomfort a little bit, because sometimes when we have that discomfort is when we do our deepest learning. So I'm going to encourage you to do that. I don't think we'll do it now. But one of the things I learned from Fosnot is this idea of providing students with constraints. And what she means by that is that if we want kids to move from counting by ones, we have to give them images where they can't do that. So this problem I came up with is a sunglass problem. And, you know, I see Deb's laughing maybe because she also did this sunglass problem recently with some students. And I've had 3 different grade 3 classes now work on this problem. And so the problem is that I need to buy 27 sunglasses for my daughter's play. And my husband sent me this picture from Shoppers. He says, there's 4 sides to this rack, they're all full. If I buy them all, will we have enough? And I said to them, I don't know, I need 27. Will I have enough if we buy all of them? And the kids couldn't count. They couldn't touch them. Right, Emily, it really encourages that group. So I have a couple of student sample works here. What do you see those 2 students doing? What strategies are they using? Okay. I have pictures of 2 of them here, and Mally's put a link to a document with a number of other student pieces of work. So if you want to see more, you can click on that document, and you'll see other student work samples. So yeah, Deb, you see one of the students is counting by that 6s and skip counting, and you can see 6 and 6 is 12, and then 18, and then 24, and that repeated addition. Right? And again, 6, 6, 6, 6. And what I found interesting about these 2 was they didn't actually draw out the 6 each time. So if you look on the sheet, you will see examples where kids have tallies or circles or dots, and those are the students, I couldn't be sure, maybe they were counting by ones, but these 2 students were actually adding 6 each time. What would you tell these 2 students to help them move to a more efficient strategy? So this is skip counting or repeated addition. What might you want them to do next? What might be a next place to go? based on what you've seen so far? Any thoughts? One of doubling. Yeah, I'd be interested to see, Deb, if they, since they knew 6 and 6 is 12, would they then do doubles? 12 and 12 is 24. Okay. And these students are just beginning to make that connection to multiplication. So you can see one of them wrote 6 times 4 equals 24. But they are just beginning to really understand what multiplication is. All right, so I've got 3 researchers now that have really developed these progressions or continuums based on research they've done with students. And then I really wanted to know what it looked like with students in the grades 3 to 6 and push it further. And what I noticed with the work I was doing is that because teachers are moving grades all the time, they're not always aware of the different strategies for multiplication and division and what that might look like for teaching students. So, for example, I have 3 teachers right now that I'm working with that are in grade 4 and 5 who have been intermediate teachers for years. And so they weren't familiar with the effective guides because grade 7 and 8 teachers don't use effective guides. They go to grade 6. And they had never seen all the different strategies we have for teaching multiplication and division. So then I stumbled across this guy named Graham Fletcher. And for a long time, he was my edu-crush on Twitter. And Jan, yes, a T-chart, a T-chart or a ratio table would be a really interesting place to go if that's something they're used to seeing. All right, so Graham Fletcher. He is known as G. Fletchy. He has a website, gfletchy.com, and he's G. Fletchy on Twitter. And he has a progression for addition, subtraction, fractions, counting. We're going to look tonight at his progression of multiplication, and it's a video. It's about 5 minutes long, and Mally will put the link in. And as you watch it, I want you to think about what you notice about how he pairs concrete representations with drawings and then symbols. And how his strategies and models connect with what we've seen from the researchers. Okay? Oh. We're going to be able to watch it right in. That's great. Okay, so I'll play it right in the PowerPoint 10. That's awesome. And then you'll have the link later to have. So let's take a look at it. Mally, is that what I should do? Should I play it right in here? Yes?
It's
No? Or should people watch?
It's playing. Do you see it? Or people can click on the link that I put and just let us know when they finish by using the check mark. Can you see it playing, Kit?
Yes, I can see it playing.
Then everybody can see it.
Okay. Has everyone done the video? It shut off for me, so almost. Okay, I'll wait another minute. Okay, so what struck you? What popped out at you? Anything that you hadn't thought about before? Any connections to your own practice? I have to tell you, I'm really good at wait time with students. Yeah, that connection of that model, Marlene, of the base 10 blocks to the drawing, to the numbers, to the standard algorithm. And Kate, what shocked you? What made you go, wow? And I didn't front load this video with the knowledge that it's from the US, so the grade references might be off a little bit. Let me just go back up a bit. Deb, you're thinking about how to fill in the gaps with older students who lack those conceptual understanding, right? Taking them back, just like I think it was you that said earlier, when the concepts become more challenging, kids have to go back to easier strategies to build and work their way through it again. And I think it's the same here. That's where you're seeing that. Emily, that progression, there's an Ontario math educator named Kyle Pierce. Is it Kyle Pierce? No, I think it's Dan Meyer from the States. And he said, you know, we need to create problems for kids where the aspirin is the answer. So how do we make what they need to do the solution? We don't show them the solution. They want to find a quicker way to solve that problem. Kate, that was the thing that really struck me, is that idea of turning the arrays with the manipulatives to drawing and then pairing them. And I really like that, concrete with manipulatives, the diagrams of the arrays, and then pairing it with the symbolic numbers and algorithms. And I think that pairing, showing two at the same time, is really crucial. So I often played a game with students where they roll 2 dice, find the product, and color that many squares in on a piece of grid paper. Has anyone else played that game? I forget what it's called. It's pretty, right? So yeah, it's pretty common. And you've been talking a lot, Annika, about having not just jumping into the standard algorithm. That's right. If we jump, then kids get the gaps. So back to this game. I played this game, and then I started thinking about how it was really good practice, but it was still pretty symbolic, even with the drawing. And I wondered about how I could make it more concrete. Okay. Yeah, how close to 100? There's a YouTube game. Thanks, Teresa. So then I ran across this game, a different version of the same thing called Rods and Rectangles. And what you do here is you roll 2 dice, and instead of just drawing, you're building the factors. You're using the factors to build arrays with Cuisenaire rods. And I think Cuisenaire rods are probably the most underused manipulative in our schools. I've seen them collecting dust. I even heard somebody the other day said he threw a whole bunch out because they'd just been gathering dust, and my heart broke a little bit. So this game is similar to the coloring in the grid, but it's rods and rectangles. and you're using the Cuisenaire rods to build the arrays and then draw them. And I thought this was a really nice way to help connect that concrete with that diagram and then into the symbolic. So I tried to show it here with Cuisenaire rods from mathies.ca so I could show it to you. Okay? So for me, the final piece in all of this is the connections, about how important it is to connect multiplication and division and make that visible to students. And often we teach them in isolation, right? So we teach multiplication, we're doing our multiplication unit, and then we do our division unit. But just like addition and subtraction, I really believe we need to be teaching them together. So I have two examples here of how I've started to combine these ideas. So pencils come in boxes of 24. I bought 8 boxes. I shared the pencils equally with 3 classes. How many pencils did each class get? So we build them up, we multiply, and then we divide out. This one, 81 parents coming to our math night. We know the total. We're going to divide by 6, put 6 people at a table. How many tables will we need? And now we have the number of tables. Each table needs 12 markers. How many markers we need? So this one is division first and then multiplication. Okay. Yeah, using them both in the same question. The sunglass problem that we did was multiplication, but a follow-up that I didn't show was, okay, so I've bought 27 sunglasses. I'm going to store them in 4 bags. How many, and I want them to be as even as possible. How many sunglasses are going to be in each bag? Okay. So again, the meatballs was really a multiplication and a division, because first they had to find out how many there were, and then they had to divide them amongst the number of people coming for dinner. Okay. So I think that is really important, that idea that we show kids how they're connected. And to me, it will take away some of the angst of division being frightening, or they don't know how to do division. Oh, sorry, Jan. Those of you who you had the link to the Graham Fletcher video on Vimeo, but if you go to his website at gfletchy.com, and I'll just put it in here, fletchy.com, then you'll be able to see all his different progression videos. And he has a great one that combines addition and subtraction. And I really like his division video as well. Yes, Kate, he is American, so when he talks about the standard of mathematical process, standard mathematical process number 7, that's a part of the Common Core standards. So the grade levels are a little bit different. He actually is Canadian, but he lives and works in the U.S. and teaches there. You can follow him on Twitter too. He's really, I learn something from him every week when I see his work. So I would encourage you to look at his other progressions, the division in particular. Those of you who are looking at operations with fractions, he also has ones with fractions. And those of you who are working with younger students, he really, before even addition and subtraction, he also has a wonderful progression about just counting. And he's done some great work. he also has some wonderful 3-act math tasks that I would encourage you to explore. So that's what I wanted to share with you tonight. We're a little bit ahead of time because our group has been a little smaller. But as I said, I'm always open to talking about math on Twitter, on email, so please get in touch with me. I'm leaving you with a couple of images that you might be able to use in your classrooms. And again, I chose these two because they show different representations of multiplication. One is that array model, but some of them are hidden, like the Fosnot constraints. You actually can't count all those boxes. And the other one are the groups of towels, which is more like our ladybug legs. Mally, right, so the recording and all of the resources, and I gave Mally a bunch of other links to include on the website so that there's more to learn, because I know that's what you want to do, because math is awesome and lots of fun. So I challenge you to try one of these things tomorrow. It's Friday. It's a great way to spend a Friday, to introduce something new. If you do any of these tasks with your students, I would love it if you sent me an email with some pictures of the student work. Remove anything identifying, but I love to see how kids solve this and, what interesting new strategies come up. So thanks very much. Thanks for hanging out with me on an April night. And reach out, and I'd love to continue the conversation.
Thanks, Kit. That was really great. We had a conversation before the session began about